Hi guys, I wanted to go over the word problems for multiplying and dividing fractions from yesterday. So when you're looking at word problems, you really have to understand the situation so that you know which operation to choose. Sometimes it's hard to tell, so I like to start with a model, and the model helps me to understand which operation I should use, whether I should use multiplying or dividing to help me solve that problem. So my first problem says that Sammy had 1/3 of a cake left. If he eats 2/5 of that cake, what fraction of the whole cake is still left? So that sounds like a brownie pan problem to me, something that we've modeled before. I'm going to start off by drawing my cake pan or my brownie pan. I know that 1/3 of my cake is left over, so I'm just going to shade that in to represent the cake that's left. And if I eat 2/5 of that cake, that means I'm going to divide it into fifths. And when I eat 2 pieces of that, I'm going to eat this piece and I'm going to eat that piece. So altogether, I can see that I have 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15 pieces in the whole pan. So I ate 2/15 of the whole pan. If you feel comfortable with that, you might be ready to think about the fact that 1/3 times 2/5 is a fraction times a fraction. If we're multiplying, we do numerator times numerator, denominator times denominator, and the answer is still 2/15. So with the multiplying algorithm and the picture, we see that the answer is 2/15. In the second question, Marcy's having a birthday party. Each person will get 3/4 of a cup of juice, and if there are 18 guests, how much juice will they need? All right, so I know that I have 3/4 for each person. So 3/4 and another 3/4 and another 3/4 and another 3/4. I'm going to have to do that 18 times, because each person is going to get 3/4 of a cup. So instead of drawing out that extensive model, I'm going to take 18 and multiply it 3 times 3/4, because there's 18 people. Each person is getting 3/4 of a cup. I'm going to do that multiplication. 18 times 3 is 54, and 1 times 4 is 4. If you turn that into a mixed number, 4 goes into 54 13 times, because 13 times 4 is 52, with 2 left over, 52, 53, 54. So with remainder of 2/4. Or you can say 13 and a half. Let's look and see if that answer makes sense. If I have 18 guests and each person is getting less than a cup of juice, we should have less than 18 cups, and my answer makes sense. For number 3. Number 3 says 1 serving of ice cream is 3/4 of a cup. For the birthday party, they used 2 2/3 cups of ice cream. How many servings was that? So I'm starting out with 2 2/3, and I'm dividing that up into serving size of 3/4 of a cup. So I'm just going to draw a model. I'm going to start with my 2 2/3. So 1 whole, 2 wholes, and 2/3 of another. This one's not here. I put an X in that one. And every serving is 3/4 of a cup. So I know that I can get 1 serving there. If I break it into fourths again, I can get 1 serving there. And now I can definitely get another serving out of what's left over, but I've got some extra, and I really can't tell exactly how much that is. But by making this model, I've decided that this is definitely a division problem. I'm taking 2 2/3 and I'm dividing it into sections that are 3/4 of a cup. So I'm going to set up my division problem, 2 2/3. I'm going to divide it by 3/4 of a cup. My answer should be 3-ish something, because I know this is 1 serving, 2 servings. That's about 3 servings, and then something over here is left over, but I'm not exactly sure what it is. But my model definitely helped me estimate. So I'm going to do my keep, change, flip algorithm. 2 2/3 times 4/3. Draw my box. Two groups of 4/3 is 8/3, and 2/3 times 4/3 is 8/9. I did numerator times numerator, denominator times denominator to get 8/9. And 2 groups of 4/3 is 4/3, and another 4/3 makes 8/3 altogether. So altogether, if I'm going to add this up, I need a common denominator. I'm going to multiply my numerator and denominator both by 3. So I'm going to get 24/9 and 8/9. And when I add that together, I get 32/9. That is an improper fraction. I know that 9 goes into 32 3 whole times. Good, that's my estimate. I know that this was going to be 3 something. So 9 times 3 equals 27, 28, 29, 30, 31, 32. That leaves me with 5/9 left over. So 3 5/9 is my final answer. And it does match my model. I knew it was going to be 3 something. Number 4. Bryson eats 1/7 of a box of cereal per day. How many days will 3 1/4 boxes last? All right, so every day he eats 1/7, and we start off with 3 1/4. So I'm going to start off with my 3 1/4 cereal boxes. All right, and I know he eats 1/7 a day. So, well, I know I can get 7 out of that box because 7/7 make 1 whole. I know I can get 7 out of that box. I know I can get 7 out of that box. And at least 1 out of here, because 7ths are smaller than 4ths. So my answer should be around 21. But I'm not exactly sure of the answer, so I'm going to go ahead and do the algorithm. By drawing this picture, I'm sure that I'm taking this number and breaking it down into 1/7 size pieces. How many 1/7 can fit into this number? So I know this is a division problem. I'm taking 3 1/4 and I'm dividing it by 1/7. If I do keep, change, flip, I get 3 1/4 times 7/1. If I do that in my box strategy, add some more paper here for us. If I do 3 1/4 times 7/1, that's a mixed number times a whole number. So 7 times 3 is 21. 7 times 1/4 is 7/4. I knew my answer was going to be 21 and then some, so that's good. My answer's close to 21. 7/4 is the same as 1 3/4. Sorry, that's kind of messy. Because 4 goes into 7 1 whole time, with 3 left over, so 1 3/4. So So altogether I have 22 3/4. Let's make sure my answer makes sense. If I can get 1/7 of a box in one day, I think 22 3/4 makes sense because it's a little bit more than 21. I can get 21 and then a little bit more out of this last piece of my cereal box, that little 1/4 of a cereal box. So I think my answer makes sense. I'm pretty confident that that's the right answer. Moving on to the back, there are 2 more questions on the back. Sarah can run a mile in 8 1/4 minutes. How long will it take her to run 5 2/3 miles? All right, so this sounds like a repeating problem to me. I know that she can run 8 1/4, that's 1 mile. 8 1/4, that's another mile. 8 1/4, that's another mile. And we have to repeat this for 5 2/3 miles. So instead of writing out this model, just like on the Marcy's birthday party, I'm just going to do a shortcut and multiply. So instead of adding up all these 8 1/4, I'm going to do my shortcut and multiply. So I'm multiplying a mixed number times a mixed number. I'm going to break all those parts down. I need to do 8 1/4 and multiply it by 5 2/3. I'm pretty sure that my answer is going to be about 40. It's going to be 40 and then some more. Because if it were just plain numbers, if I could run a mile in 8 minutes and I ran 5 miles, 8 times 5 would give me 40. And that's the first piece of our box right here. 8 times 5 does give us 40. 5 1/4 is 5/4. 8 groups of 2/3 is 16/3. And 1/4 times 2/3 is 2/12. All right, changing this all into mixed numbers, and you can find your common denominator and then change it, or you can change it and then find your common denominator. At this point, the order doesn't really matter. I know that this is 1 1/4. I know that this is 6 goes into 4 times. Hold on, 3 goes into 16 4 times because 4 times 3 is 12. 13, 14, 15, 16, that's not enough. Oh, it can go in 5 times because 3 times 5 is 15 with 1 left over. So this is 5 1/3 and then 2/12. So I'm going to add up all my whole numbers first. I've got 40, 45, 46. So I know I'm definitely going to have 46 wholes, and the rest of my fractions I need to gather up and add them together as well. I've got to add 2/12, 1/4, and 1/3. So for my 1/4, my 1/3, and my 1/12, I need common denominators. That gives me 3/12. That gives me 4/12. And my 1/12 stays the same. So I've got 7 8/12. If we want to simplify that down, we can say it's 46 4/6. If we want to simplify it down even further, we can say it's 46 2/3. And for the last one, Martin has a board that is 4 3/4 feet long. If he's cutting it into pieces that are 2/8 of a foot, how many pieces then can he cut? I'm going to model